If it is emitting electrical lines of forces, it will be a positive charge. And if it is receiving electrical lines of forces, it will be a negative charge. The lines of forces are indicated by small curves. Like in the figure, it is shown Q greater than 0 means positive charge and Q less than 0 will be negative charge. Now, on the small curves, if we select 2 points, closely spaced points, between those 2 points, the curve will appear to be a straight line. So, if it will be a straight line, then we will find that electrical lines of forces conventionally can be represented by straight line also. So, electric lines of forces are represented either by curves or by straight lines, like shown in the figure. Wherever we write Q greater than 0, it will be positive charge, and Q less than 0 stands for negative charge. The space or the region around the charge in which electrical lines of forces show their effect is known as electric field. The electric line of force in electric field are spread in 3 dimensions as shown in the figure. In the figure 1, in the sphere, we find the lines of forces are curves, and in the adjoining figure, we find that we have taken 3 axes, and on the 3 axes, we have shown the electrical lines of force. We will further remember that electric field is given by force per unit charge. F stands for force and Q stands for charge. Moreover, the unit for force can be taken as Newton and the unit for charge can be taken as Coulomb. So, electric field can be Newtons per Coulomb. The electric field has tendency to exert force on any other charge placed in electric field. Electric field is a scalar quantity, but electric field intensity is a vector quantity. Vector has both magnitude as well as direction. The force experienced by unit positive charge within electric field is known as electric field intensity, represented by ER, I or F. These are the representation of electric field intensity or intensity of electric field. Moreover, SI and MKS units of electric charges will be Coulomb, whereas the CGS unit is stat Coulomb, or electrostatic unit of charge, that is ESU. 1 Coulomb is 3 into 10 to the power 9 electrostatic unit of charge, and 1 ESU of charge can be taken as 1 over 3 into 10 to the power minus 9. If it is simplified, we find that the order of 1 electrostatic unit of charge will be 10 to the power minus 10 Coulomb. The unit of electric field is Newton per Coulomb, MKS, and in CGS system, it is taken as dyne per electrostatic unit of charge. The units of electric field ER can also be taken as volt per meter, MKS, or electrostatic unit of potential per centimeter, that is CGS. You will further remember that MKS unit of potential is smaller, whereas CGS unit is bigger, and 1 volt is 1 over 300 electrostatic units of potential. That is, 1 electrostatic unit of potential will be equal to 300 volts. Now, in most of the cases, we use the units of force also. However, we have read it in the 11th class, but now Newton and dyne, they can be used in the various numerical problems. So, Newton is MKS unit of force and dyne is CGS unit of force. 1 Newton is 10 to the power 5 dynes, whereas 1 dyne is 10 to the power minus 5 newtons. The absolute unit of force is given as F is equal to ma, where m is mass, a is acceleration, and the statement is known as the second law of motion. For mass, we can put 1 kilogram, and for acceleration, we can put 1 meter per second square. So, 1 Newton can be equal to 1 kilogram into 1 meter per second square. 1 Newton is the force acting on a mass of 1 kilogram, producing in it an acceleration of 1 meter per second square. Similarly, the CGS unit is dyne, and 1 dyne is the force acting on a mass of 1 gram, producing in it an acceleration of 1 centimeter per second square. Then we can prove that 1 Newton is 10 to the power 5 dynes. Kilogram meter per second square means Newton, whereas gram centimeter per second square means dynes. Then in the gravitational units, they depend upon F is equal to mg. where F stands for force, M is mass, and G is acceleration due to gravity. So serious gravitational unit is gram weight, whereas MKS gravitational unit is kilogram weight. 1 gram weight is 1 gram into 980 centimeters per second square. So here we can prove that 1 gram force or 1 gram weight, that is equal to 980 times in serious system. Moreover, weight is the force due to which bodies are attracted towards the center of Earth. Then 1 kg weight or 1 kilogram weight in gravitational units is taken as 9.8 newtons. The dimensional equation of electrical quantities are generally represented in terms of mass, length, time, and amperes. That is correct. Dimensional equation of electric field can be estimated by using a function E is equal to F over Q or E is equal to V over L. V is equal to W by Q and W is equal to F into L also. So if we will put all these values in the given equations, the dimensional equation of E will become ML T minus 3 A minus 1. Similarly, dimensional equation of charge, that will be ampere. So it will be M naught L naught T A. Dimensional equation of potential or potential difference will be MLT minus 3 A minus 1. Now, after that we have to discuss what is test charge and what is the source charge. Regarding test charge, we have to remember that its representation is Q naught and source charge is represented by Q. Test charge has tendency of experiencing force due to electric field which is generated by Q. The charged bodies and most elementary charges will be electron charges. Now, quantization of charge means that if a body is made up of n electrons and charge of each electron is E, then according to the quantization of charge, we will find Q is equal to Ne. This can be further applied to Coulomb's law, and for Coulomb's law, there will be certain exceptions, and formula of force due to electric and force due to magnetic field, that can be specified in the coming article. Q naught is test charge, that is having no field of its own, and even if its field is there, it will be so small that its field will be represented as delta E is approaching to 0. Moreover, test charge Q naught will not exert any force on the source charge, whereas source charge is having significant electric field, that is E. The source charge Q exert force experienced by test charge Q naught. So the source charge Q will exert force, and that force is experienced by test charge Q naught. After that, we come across stationary charges and the moving charges. We find that stationary charges constitute or interact only with electric field, but moving charges constitute or interact with electric field as well as magnetic field. Magnetic fields are represented by B, electric fields are represented by E, and MKS or SI unit of B is taken as Tesla or Weber per meter square. 1 Tesla or 1 Weber per meter square are numerically the same, but serious unit of magnetic field B is Gauss, and 1 Tesla is equal to 1 Weber per meter square or equal to 10 to the power 4 Gauss. So if we take an inverse number, 1 Gauss will be equal to 10 to the power minus 4 Tesla. And force exerted by electric field is given by F is equal to EQ naught, because electric field is F over Q naught. Force exerted by magnetic field is F is equal to BQ naught V sine alpha, where V is the velocity with which Q is moving, B is due to Q exerting force on Q naught. Q naught has no significant field. Alpha is the angle between the direction of motion of charge and the direction of magnetic field. Motion of charge and the direction of E and B are indicated in 3 dimensions according to Lorentz convention. So it is shown the Lorentz convention. We have taken 3 axes, x-axis, the y-axis and the z-axis. The choice of axis is arbitrary. It is not necessary to indicate electric field on the x-axis. However, it can be indicated on y-axis also and vice versa. So here in the figure, electric field is shown on x-axis, the magnetic field on y-axis, and the motion of charge that is indicated on z-axis. So the velocity of the charge will be along z-axis, and all the three axes are mutually perpendicular. Therefore, the formula for magnetic field will be F over Q naught V sine alpha. If alpha is not given, then it means that alpha is considered as 90 degrees. OX, OY, OZ are mutually perpendicular, and sine alpha in the equation can be taken as sine 90, that is 1. So B is calculated in Tesla. 1 Tesla means 1 Newton over 1 Coulomb multiplied 1 meter per second. So how to define 1 Tesla? 1 Tesla is the magnetic field exerting force of 1 Newton on a test charge of 1 Coulomb when source charge is moving with speed of 1 meter per second at 90 degrees to field. Generally, unit positive charge is taken as a test charge and unit positive charge is 1 Coulomb charge in MKS, whereas in CGS system, it is 1 ESU of charge. Electrical line of force is the path traced by unit positive charge within electric field. The magnitude of electric field is calculated by Coulomb's law, and in order to find the direction, a point is selected on electrical line of force and the tangent is drawn at that point. The direction of tangent gives the direction of electric intensity. Now, the next thing is we will remember that when bodies are rubbed together, we find that electrons transfer from one body to another body. So positively charged body is one in which there is deficiency of electrons, whereas the negatively charged body is that which has excess number of electrons. So positively charged body is deficient and negatively charged body is having excess of electrons. If we compare their masses, we find that mass of the positively charged body is comparatively less as compared to the mass of the negatively charged body. The magnitude of proton and electron charges are given as plus minus E modulus, that is written as E. And the numerical value of E in MKS system is 1.6 10 to the power minus 19 Coulomb, whereas in CGS system it is 4.8 into 10 to the power minus 10 electrostatic units of charge. Now, when bodies are rubbed, electrons are transferred between the bodies. The total charge is conserved. There is nothing known as the loss of charge or the gain of charge, but the conservation takes place. And the total charge Q is an integral multiple of E. So Q is equal to NE, where N is equal to plus minus 1, plus minus 2, plus minus 3. This equation is known as the quantization equation. From this equation, we can calculate the value of the number of electrons, that is N is equal to Q by E. If Q is 1 Coulomb, E is 1.6 10 to the power minus 19 Coulomb, then the number of electrons estimated will be 6.25 into 10 to the power 18 electrons.